This one's right. Hello everyone, it's April 29th. Let's do this. Number of wonderful substrings. A wonderful substring is a string where at most one letter appears an odd number of times. For example, CCJJC is wonderful because you have C occurs odd number of times. Now, I need to get some water first. AB are wonderful. Oh wait, hold on. At most one letter. Okay. AB are wonderful because no letter is, but AB is not. Given a string word that consists of the first 10 lowercase letters A through J, return the number of wonderful non-empty substrings in word. If the same substring appears multiple times, then count each occurrence separately. So ABA, we have A, B, A, AB, BA, these are not, and ABA. ABA and ABA. Alright, let's try some sort of DP. We want to count the number of wonderful substrings ending at each position, okay? So the number of wonderful substrings ending at here is 1. Ending at this, I have 1. And I need to know the number of wonderful substrings ending at the previous one, right? And I say they have at most one letter appears an odd number of times. So either everything is even or at most one is odd. Okay, so when I look to my left, right, I have the number of wonderful substrings. So if the wonderful substring contains no odd counts, then the next one, we can add it, right? It'll be fine. But then how about the next one? Huh. Interesting. Maybe that's not the way to go. Yep. So how about we change our idea? Because right now, if I have even number, okay, everybody is even, or I have one letter, I know. If I have two letters, right, if they're different, then it will be 0, right? If two letters are the same, that will be 1, 2, 3. Okay, so 3 letters, right? Let's just go 3 letters, right? If I have 3 letters, 1, 2, 3. If I have 3 letters, depending on what the previous 2 letters are. So if I have 3 letters all different, the answer is just 3, right? The answer is just 3. If I have these 2 are the same, but this is a different, then ending at here, it's maybe I need to do something different. Maybe I need to count the frequency of the letters. Count the frequency of the letters. What do you mean by count the frequency of the letters? Okay, so what if I, document? I can have a failed one, right? If I have AB, that's a fail, but if I A again, then this is a wonderful substring. Right? If we're looking at here, I say it's bad, but what we need to look at is the entire thing and the number of odd count. Number of even odd count. What if they say 10? I think I kind of know what it is. I think it's bit masking. It's bit mask. Right? It's bit mask. So I have a bit mask to report. Yes, I have a bit mask to report. Hold on. I have a bit mask to report up until I can have, all the previous. Yeah, this must be bit masking. Okay, how do we do this? So we got a new one. We want to know ending at this, right? So we can exclusive or a 1, right? Which means what I want is all the previous. Yeah, because the count is limited, right? Because you have 10 positions, and then we'll see the previous pattern, like how often has it occurred, right? How often? So you just exclusive all at that position. So like if I have a B, right, which is gonna be a 1 0, right? It's gonna be 1. So basically it's like this. It's gonna be a 1 0. So if I add this, what I want to know is ending at this. All the substrings ending at this. All the substrings ending at this. That has. So it's either 0, because 0 are exclusive of this, that I have 1 1, or it has to be a 1 0 as well, and then exclusive of this, it becomes 0 0. That is the only possibility. Oh no, that's actually not true. We can have a 1 at each position. Right? It doesn't really matter where. We can have a 1 that exclusive of all, then that's become true. So what you're saying is if I have the the frequency of all of these, how many are there? That's because it's 10, so it's 2 to the 10th, right? What's 2 to the 10th? Is that actually I don't know, 1,000? Yeah, 1,024. So I have to go through 1,024 different scenarios. For each scenario, we just check if it exclusive or this get me. Actually, don't even need to. I have only 10 different possibilities. Yeah, it's just 1, 1 0, 1 0 0, 1 0 0. So only these. That is bonkers. That's not right, dude. Come on. What I have is a 0, right? And if I have 1 0, I can do a 1 0, so it's the same. And then I can have a 1, right? I can do a 1 1, because I can only have 1 1, right? So it's 1 1, 1 1 0, 1 0 1 0, 1 0 0 1 0, like this. So at this position, all become 1, and then I move 1 to the right. Basically means this exclusive of 1, exclusive of this, it becomes 0, and then exclusive of this is, yeah. So all these I just need to check how the count, right? The count previously. Okay, and then what? And then you just go through everything. That's because we have the bit masking for ending I hear, right? Ending I hear, I said I have a frequency. I have a frequency of all of them. I know how many times they occur. And then I just go, everyone I exclusive of this, because I add that to it, and I got a new one. I think we're seeing the thing. Yeah, so we have an array of length 0 to 1, 0 to 3, right? That's the one. So for each one, an exclusive of whatever this is, this will give me the new, right? No, so I go through it twice. First, I go through the ones that can make it work, make it into a wonderful substring, and after doing that, I go through everything and exclusive of this. This one will give me, right? This one will give me the current, right? The current. So I just need to know what are the frequency of the previous. Yeah, so start with 0, right? Start with 0. So the previous frequency is just 0 because I have 0. So 0 exclusive of this. Now I have the current, right? And then for B, I go through all possibilities. I get my count. And after I get my count, I go through the previous available, which is 0 and whatever it is. So I go through and then I have a couple more and a couple more and a couple more. All right, let's try this. So what you're saying is I need to use a map, right? I have to use a map. It's the frequency, right? It's the frequency, and a map looks to be more reasonable in this use case. So I'm just gonna go a map. All right, so we need a map. We can say map integer and integer. We call it bit mask, right? New hash map. And then I'm gonna go through the word one by one, right? Go through the, not the word one by, go through the letter one by one. Now we say for char c of word dot to char array. Okay. Now for each one, I need to get, I need a bit mask dot put. 0 is 0 because I have 0 count. This is 0 doesn't exist, right? So 0 is going to be 0. So each one, what I'm going to do is I have a res as well, int res equals 0. So I need to go through. So for int I equal to 0, I smaller than 10 I plus plus, right? Because I can go left shift 0 times, right? Left shift 0 times, so that's just 1. And we'll left shift once, 2, 3, 4, all the way left shift. Because left shift 3, 1, 2, 3 is 4. Because I can have at most 10 digits. Left shift 9 is the most I can do. So with this, what I need to do is left shift. So 1 left shift. So I need to know the current, right? The current position. So int position shall equal to c minus a. All right, this is the current position. Then I can say the target, int target, int t. Okay, we can do int target equal to 0. Doesn't matter what it is because I'm going to reassign it. So what I'm going to do is I say target equal to position exclusive or, come on, position exclusive or 1 left shift I. Okay, so that is the one that I need, right? And then I can say res plus equal to bit mask dot get or default target, and default value is going to be 0. That just means I can get that many to, if I including me, they will fulfill. So we add that much, we add that much, we add that much, right? And then once we're done with all these 10 positions, what we're gonna do next is go through the bit mask, right? Because they are ending at everything, and I'll exclusive all whatever I have right now. Because if I exclusive all, if it's even number, I exclusive all, it becomes odd, right? So what we're gonna do is we have to go through everything, and I need to change. Now that might not be what we're looking for, because I need to have 2 copies. Okay, I need to have 2 copies, so I need to have a map integer. I don't think I can change in place unless I can get the keys out. Can I get the keys out? Can I get the keys out? I mean, I can get the keys out, but the value will be updated, right? The value will be updated. I don't want the value to be updated. I want the original value. So let's just now make a copy. So we'll call it temp. Okay. New hash map again, and then we say for int b of bitmask dot key set, right? For each one, our exclusive all, right? I will exclusive all the current, and then get a new one, right? And then I will assign that value into the new one, right? Because this is like kind of the new value, and I assign it to put a new one. So I say temp dot put b exclusive all position, right? B exclusive all position. That is the new condition, the new frequency, right? The new frequency that shall equal to bitmask dot get b dot get b, right? Bitmask dot get b, because we have that many count, right? That many count. But where is +1? You're not doing +1 at all? I should do +1, right? Because if that doesn't so the previous one, if I have, you know, let's say 5 occurrences of the previous bit mask, right? Now you're adding the current one, right? You're adding the current one, and the current one added each of them the frequency change. So you still have 5, right? You still have 5. Yeah, I don't think it's put. It should be put this, and shall be temp dot get all default b exclusive all position. Default shall be 0 plus bitmask dot get b. Right, that's that. Okay, and at the end we need to add one more, which is just b by itself. So temp dot put. Actually, before we do that, I can say temp dot put position is 1, right? Because we always have that. We always have the current position because by itself we have 1 count, and then we go through this, we get this. Okay, so at the end, once we're done, go through all the bit mask, right? All through all the bit mask, and I get a new one. The old one gets discarded, and now we say bit mask shall equal to temp. Okay, now we go through. At the end of return rest. All right, so I'm pretty sure this one we can do that. Okay. Target is not used because I'm not using target. All right. So bit mask, we do this, we do this. Ooh, I think the temp has to do that one as well. I think temp need to put 0, 0 as well. Oh, do I even need to though? Do I need to? Interesting question. I don't think I need to. Right? I don't think I need to. So I don't do this, and I don't do this, and I put this as 1 already, right? If I do put a 0, then I have to do it here, because a 0 exclusive of myself is myself. Then bitmask.get. Let me think again. So we don't put a 0, which is fine, and as we go through this, everything will be nope, that's not right. We need to put 0. Because when I put 0 at the original, then this get out default. When these two are the same, then I get a 1. So that's how a result will get a 1. So I need to put 0, 0, right? And if I put 0, 0, then here, bitmask contains 0, right? And 0 exclusive of this, right? And then we'll put this and temp.get or default. Get or default. This will be a 0, right? Then it'll be a 0 plus bitmask. Now get its key. I mean, whatever key it is, right? Whatever key it is. I do think this we have to put the current position as 1, right? We put a current position as 1, and then we have the previous, right? The previous, all the previous in the bitmask. Okay, all the previous in the bitmask, including 0, right? Including 0. That's awesome. Okay, including 0, and then I will get, right? I'll get now, because B including 0, so this will be position exclusive of 0, right? And this will become 1, and plus yeah, because that's by itself, right? That's by itself. We want to find the new frequency, so at least we have to include this one. And if previous, I think this is fine. I think this is fine. We put 0, we put this, right? We put 0, we put this, and then we go through and we get this, and then we return. Okay, let's take a look at see if this one works. Does it work? Okay, doesn't work very well. Let's take a look at why. So the first one, ABA is not working. ABA is not working. ABA. So I have bitmask. I have 0 is 0. Rest is 0. So I have A. So position is 0, right? Position is 0. So bitmask we try to find. That's gonna be. I think we should put 0 as 1, right? Because I am saying get or default, right? So if I put 0 as 1, then when we hit that, it's gonna give me 1, right? So I think I should put this as 1. Then I should put this as a 1, and I don't need to do this because 0 will be 1, right? And then this will put, and I go through all the previous, then how do I get mine into it? Right? How do I get a mine into it? Because this is the previous key, right? This is the previous key, each one exclusive on my own, right? Each one exclusive on my own. Then I'll add whatever the previous one is, and at the end, because the one's ending, right? That's what we want to do. The one's ending. So bit mask is the previous one, right? Ending at this. Previous one ending. Let me see. Previous one ending at this is nothing, right? Previous one ending is nothing. So now the current one come in. I have the frequency, right? All the frequencies. And then I need to get every one of them, right? So the previous frequency is just a 0, right? Just a 0. And then for every one of the previous frequency, I exclusive for mine. I get a new thing. Then I plus the previous frequency, right? I get a previous frequency. I get the previous frequency. Now bit mask is the previous frequency, right? Bit mask is the previous frequency. Yeah, bit mask is the previous frequency. And then I have the current. I need to find the previous frequency. I need to find the previous frequency and how many do they exist. That if I exclusive on mine, with that, I can get a good result. And for me, that basically means previous a 0 should be a 1, right? Then I exclusive of that, then it will give me 1, right? Because it's a 0, so one of them will become 0, right? And once we're done, right, that's the previous frequency. Once I'm done, and then go through the previous frequency, right? And then the previous frequency, they have a 0, so the 0 exclusive of mine, so that's a new value. Then I'll add that, right? I'll add a bit mask dot get the previous thing, right? And I also put a 0 into it. Right now we can, let's try this one. So we add a little bit change. Okay, the first one is right, and the rest is still not right. Okay, let's try the last one. Again, at first I got a 1, right? And then I go to the next one. Next one is a E, right? An E. And then I go through all of this, and bit mask shall have a 0, right? One left shift 0, one left shift whatever it should be, then the position, because I'm minus a, whatever the value. Oh, it's not this. My bad. It's 1 left shift this. Position is 1 left shift. Okay, so now I have only 1 to go. Okay, yeah, the position is 1 and the left shift, right? 1 left shift. That's the position. And then we can do, yeah, it is a position, right? Position, and then we can do this, the position. That's good. And then temp is a new hash map. And then we say for the previous, right? Previous. And the previous will include a 0, right? Include a 0 will be a 1, so the current will become a 1. right? The current will become a 1. Bless you. Right? I only got 6. Position exclusive wall, 1 left shift I. Yeah, because if I have this, then the count of that shall satisfy me, right? So I have A. You know what? I can do this. Let's explore this. AAB. Okay. Let's explore this. AA and AAB. Okay, so the first one is not right. Okay, so the first one, my output is 2, but it should be 3. So what happens is I need to add more at the end, right? Because I handled everything, and then when it's done, my bit mask contains whatever, right? Whatever my bit is ending at the last one, but that one has not been handled yet because I need something to handle. So now what I have is a bunch of bit masks which is ending at the last one. Now we need to go through them and then count the one that has at most 1, right? At most 1. So what we need to do is go here for int b of bitmask dot key set, right? What we want to do is res plus equal to b dot integer dot bit count b. Is it smaller or equal to 1? If it is, we'll add bitmask.get b. Otherwise, we'll do 0. Yeah, we are missing this function. And when we add this, the result shall be right. The result is not right. Okay, that is not expected. Now I'm getting too many. Interesting. Yeah, I already get it, right? Because this one I already get it. This is the last digit out. I'm trying to see the previous. What do you have? I'm gonna add myself. Right, if you have this exists, then it fits. If that exists, then fits. And then I go through them at exclusive of myself, and I produce a new one. Right, I produce a new one. Then why don't you just go through and then do this? Right? Why don't you just do this? Don't need to go do this. All I need to know is, because I have the frequency of the previous one ending, now I just go through the whole thing. So what I'm suggesting is, you go through the bit mask, okay? You go through the bit mask, you updated it, right? You updated it. These are the ending at, right? Ending at. So yeah, you go through the previous. I don't know why it's so hard to understand. You go through the previous, and then you say the new frequency, right? The new mask, okay? So you say int. When you say mask, shall equal to b exclusive of position, right? And then we say, oh, we kind of do need. Okay, let me do it here. So here's my new idea, right? So we don't do this. We still have this. Don't do this. We do this, right? I think it should be put as 1, right? And then we got a position. That position is wrong because it should be 1 left shift this thing. That's your position. And then I got a new temp. Temp put this in. And then for this, right, for this, I'll say new mask shall equal to b exclusive of the position. Okay, so that's the new mask. Okay, that is the new mask. And then I will put it into the temp. So temp dot put new mask, and it should be temp dot get or default. This mask, no, yes, mask. Default shall be 0 because I don't have any, right? And plus bitmask dot get b. Right, so we go through this. We go through this, and at the end, I just say go through this again, right? For int b of bitmask, not bitmask, temp dot key set, right? And we say rest plus equal to b integer dot bit count. B is that smaller or equal to 1. If it is, we'll say temp dot get b. Otherwise, I do 0. All right. So once this is done, I don't even need this. I update it. This shall be a question mark. Okay, let's see this one. Is this one right? We're talking exclusively of frequency. That is still not right. Okay, why? So A is 0. So 1 left shift 0 is going to be 1, right? We have position 1 at letter A. And then, yeah, this is fine. And then bit mask, I only have 0. Okay, so the current mask is 0, exclusive of position as 1. So that result is 1. So temp dot put 1, and temp dot get, that's with 0, and b is 0 is 1. So I put 1, right? 1 with a current mask, 1. Done. Then we get out. B is 1. It's smaller or equal to 1. And then temp dot get b is 1. So rest become 1, right? Rest is 1 at the moment. So bit mask equal to temp. So come up. Now we have the second one, right? We have the second one. So second one goes in. Position is still 1. Okay, still 1. So previously I have a 0 and I have a 1. So the 0, let's say, come out first. So the current one gets count 1. And then a 1 come out, right? 1 come out, exclusive it becomes 0. Then the 0 becomes 2. Huh. 0, because I have a 0. Now exclusive is a 0. So this is a 1. So we 1 plus 1. So 0 becomes 2. Right? 0 becomes 2. So I have a 1 and I have a 2. And then I go through this. So a plus 1, a plus 2. So the answer shall be 4, but I am 5. Okay, there are many things wrong, I feel like. Many things wrong. Huh. Many things wrong. Okay. Okie dokie. Alright, I don't do this at all. I just do this. I do this. I don't do this at all. I go through this, right? And I do it. And after that, I shall say temp dot put. Just by myself, because I can form a string by myself, right? So put position temp dot get or default position 0 plus 1. Then I go through this. Let's see if this one gets to work. It's a much simpler compared to previous. Now this one's working. Okay, so I think when you add a 0, 1, it kind of just complicates things, right? It really complicates things. Now what I want to ask is, do we even need the temp? I mean, first let's just try to see if everything still works, and everything still works. So now we can consider, do we need this extra hash map? Can we do it like in place of the previous one? Now the answer is no, because if we do it in place, then affects the computation because we are making changes, right? So the next one, if the same one gets to get called, and it will be different. So I do think we have to do it this way. Yeah. Okay, so let me write some comments here. Okay, so there's a LeetCode 1915. Use bit mask to represent the frequency of the oddity, right? Parity of the parity of each position for each letter, right? The parity of each letter among substrings ending at each letter in word, right? And then when a new letter is encountered, we update the frequencies and then accumulate the count of the frequencies whose bit representation contains at most one set bit. So that will be ON times this. All right, I have confidence that this one will work. So let's just run this through and we'll see that it shall work. Time limit exceeded. Wow. I thought it will work, but turned out it did not. Huh. Can do it because it's 1000 and this is 10 to the 5th, so we cannot do 1000. Okay, that's fine. So basically we cannot run this. So this one timed out basically. Yes, it's understandable that it timed out, which is not too big a deal because we do have another idea. We will do it right now. Okay, we'll do it right now. Solution number 2. Right, solution number 2. So this uses the same idea, right? So we say similar idea as above, but we actively search for the possible, right? For the possible frequencies to use for the current letter. So now we do still have to do that. We can dot keys, but we still need to go through the previous dot keys, right? We still need to go through the previous dot keys. Maybe we can hold a second. Maybe what we can do, because I go through this, right? I go through this, I'm getting a new thing. So why do I have to go through this again? But this, I mean, I don't really think it. So we have to go through this once. So the hopefully is I don't have to go through this another time. Because I have to go through this, right? The frequencies. This we have to go through this. Right? We have to go through the previous frequency, and then I do the bit masking? Okay, so one thing is we don't use the bit mask. We don't use the map. Okay, we don't use the map. We use int bit mask. Yeah, but then they have to go through this all the time. Let's try. So we have a couple of candidates that we can try. So this one, let's say int bit mask, go to new int this, all right? And then rest equals 0. So we do this, and then we say int temp equals to new int 1024, right? And then we just say for int b equal to 0, b smaller than this, b plus plus. Okay, we do this, and then we say temp b plus equal to temp no, bit mask actually not b, mask b. So do this, right? And then temp 0 plus equal to 1, and then we go through this one more time. Actually, it can be v. No. The bit count, right? The bit count. That may take some time. Maybe we can do it that way. So we avoid doing bit count, right? So we have position is this, right? We know the position. Then we just need to go through the previous bit mask, right? The previous bit mask, and to see if any one of them can handle the current one, right? So whatever they have, they have the frequency, right? The frequency this, frequency this, frequency this, and I always add 1, right? I just simply always add 1, which is just by myself, right? By myself. So I can say for int I 0, right? I smaller than 9. It's the same as before. I plus plus. Okay. I say rest shall plus equal to bit mask 1 left shift. No, it should be the position, right? Exclusive all 1 left shift I, right? 1 left shift I. And then rest always plus equal 1 because I have the current one. And now we do this, then we do this. I don't have to do this, right? So each time I have the previous frequencies and I do exclusive or for the current, right? For the current, and right, we do, hold on, maybe one of them I shouldn't. Temp 0 plus equal 1. Temp 0. It's not temp 0. It's temp position plus equal 1. Right, it's temp position plus equal 1. Right, so it's always going to be saving all the possible. Because yeah, you're the first one, nothing happens before. Okay, let's try this one. See if this one at least works on the simple cases. it doesn't work on the simple case. We have exactly the same error as before. So I go through the word one by one, right? And then I say I is 0. So position exclusive all. So I shouldn't say plus equal to this, right? I mean, it should, because it's my position, and at one of them, this will be bit mask 0, right? It'll be bit mask 0. So you will add that. Bit mask 0 and the bit mask whatever, because the bit mask represent the state, right? The previous parity state. And then once we get all that, I say rest plus equal 1 because I can always have my current by myself, right? I have the current by myself. So we're trying to count. And I got a new temp. Right, and we go through all of them. Now we have a new mask. Right? We have a new mask. And temp this mask will plus equal to the bit mask, whatever it is. And at the end, the position, just by itself, I will add 1. Hey, why is this not right? Why is this not right? So, first come out is A. Position is just 1, right? And then I go through, I mean, there's nothing. Because this is all 0, so it's 0. So rest will plus equal 1. And then I go through everything. And everything is still 0, right? Everything is still 0. So now I have just position 1 is a 1, right? Position 1 is a 1. So bit mask. So next time come in, right? Position is still 1. And when this is 0, so 1. When this is 0, so bit mask 0. Bit mask 0. Huh. Huh. Because I want a previous as 1, right? Then I should exclusive. Should I exclusive all? Right? Because I want. Because if previous is 1, so I'm as 1. So I need exclusive of 0 to get there. So I need exclusive of 0. Right? I need to exclusive of 0. I need to exclusive of 0. And then 1 at each position. Right? So because I think it's not exclusive all. I think this should be all. Because your position and 1, I think that's all. Okay, so I got 2 right. Oh. So I think this shall be Yeah, bitmask is a previous state. So previous state is going to be, you know, 1 1 1 1 1 1. So yeah, 1 goes through everything. But previous state is 0s also. So I think what I need to do is rest plus equal to bitmask 0. Right, whatever, maybe 0 it has, so I have to add a 0, but if it is 0, I can add 1, it still works. And this is by itself, right? This is the current character by itself. Okay. Try this. Okay. All right. Let's try to see if this one works. Plus, this avoids calling bit count, right, repeatedly. Also, we use an array instead of hash map. I think this one definitely helps as well. All possible previous states that can lead to the current char being the end of a new wonderful substring, right? And then this is creating the frequencies of parity of the new substrings ending at the current char. All right, let's give this one a shot. Let's hope this one will not time out. Okay, the answer is not right because it's a long. All right, long. So I'll do long. Oh, bit mask. That is frequency, right? Damn it. I think everyone has to be long. And this is long. This is long. Long. This is fine. This is fine. This is fine. Okay, let's try it again. Nope. It's not the problem. What was the issue? Yeah, because this is not even in the long territory. 10? I don't know. Why the 9? There we go. Hooray! Alright, so it's bad. It's very bad. We have to deal with this some other time. You know what? I kind of want to get the technically, right? It's still the same runtime, right? O(n) times 10 to 4, but because I'm saving myself the use of, yeah. So there's one more thing we can try is, so we use this one again, right? But with all the tweaks of you doing this. You know what? Let's give this one more shot. Okay, let's do this one more shot. Let's do this one more shot. I'm gonna use this again. Alright, I'll call it solution 3. So we'll say this is active search plus hash map. Okay, so we do this, actually this is gonna have to be long integer. Wait, do we have to do a long? I think we have to. So this is the same, position is the same, and then I'll copy this thing, right? So we say this. Okay, so what we're gonna do is paste this. Okay, position for this. Bin mask rest plus equal to bin mask dot get or default. Okay. Default what? Position exclusive of this or 0. Right. Once we're done, we'll bin mask dot get or default 0. This will be 0, right? And then do that. Then we get here, same thing. We'll do long and b dot no. Yes. We're gonna mask. Then put mask dot get 0 dot plus yes, and after done, temp dot put position temp dot get or default position and 0 1 plus 1. Right, so we do that. Oh my god, I already have this. We don't need this. Okay, so this is the last attempt. Come on. Last attempt. Let's see if this one give us slightly better performance. So previous 27 milliseconds. How much do we get here? What? Int cannot be converted to long. Okay. How about this? Oh my god, this probably. Damn. Okay, long 0 equal to long 0. I never realized I have to do that. There must be a better way to do it, but honestly, I don't know. So I have to use, 0 0. Every time get our default, I have to use 0 and get our default 0. Okay. How about this? 515 milliseconds. That is not going to pass. All right, that is not going to pass. So I'm not going to even to run this. It's going to time out. It will time out. So no, that's not the way. Yeah, this is not the way. All right, but we solved it, just very poorly. We have to deal with this again. Anyway, that'll be it for today. I'll see you guys tomorrow. Adios.